So, for example, it's been a little while here. I'm going to get some hands on this. How would you read that? Don't call it out. I'll get some hands on this. I see 1, I see 2, I see 3. David, how would you read this?
The definite integral
The definite integral
of f
of x with respect to x
from A to B.
from A to B. Definite integral of f of x with respect to x from A to B. Lewis, you okay with that? That's how you read it. What does it mean? What does it mean, Lewis?
The area from A to B with x-axis.
So it's the area from A to B bounded by the x-axis, and you forgot something though.
The graph.
And the graph. So we know about the definite integral. You guys have been able to evaluate the definite integral on your calculator. We're able to evaluate the definite integral doing some area stuff. Today life is about to change. Meyer, can I get you to read the introductory paragraph? On page 5?
Let's see how far we've come. Until today, our knowledge of integral calculus has only involved definite integrals. Integrals of the form integral of f of x with respect to a.
Yeah.
And x. I know from past experience that the definite integral of f of x with respect to x represents the area bounded by the function f of x, the x-axis, and the vertical lines x equals a and x equals b. In some cases, we have been able to evaluate the definite integral using our knowledge of geometry. In other cases, we have had to rely on our graphing calculator to evaluate these expressions. We have also explored properties of the definite integral, worked on application problems involving definite integrals, such as rate functions, physics problems, etc., and uncovered possible theorems involving definite integrals, such as the fundamental theorem of calculating the average value of a function.
Okay, I want to stop you right there. Familiar stuff? We've been here. It may seem like forever ago. It wasn't forever ago. It was this time called before Thanksgiving break. Okay, so that's all the things that you know about the definite integral. So the definite integral, our notation is the integral of f of x with respect to x from A to B. And the big question, there is a question being asked by this notation. God bless. And I really care about your understanding of the question. When you see this notation, the question that should be in your head is, how much area, or what is the area, how much area is bounded, and we know this bounded by 4 things. The 4 things?
The x-axis, the graph, and the vertical lines, A and B.
Okay, so bounded by the graph, the x-axis, x equals A, and x equals B, and maybe on the side here you've got some little picture. You're like, here's my function, here's x equals A, here's x equals B. That's the area that I'm looking for. This is what a definite integral means. Everybody okay? We're going to switch gears now. We're going to switch gears into something called the indefinite integral. And Celeste, if you could pick it up from there.
Now we need to add the indefinite integral. The indefinite integral of f of x?
The indefinite integral of f of x.
With respect to x is our toolbox of calculus concepts. The indefinite integral is the function which has f of x as its derivative. In other words, we are looking for the antiderivative of f of x. Mathematically, this means the following.
Okay, so I want to stop right there. What's immediately, obviously different between a definite integral and an indefinite integral? Lewis, what's different?
There's no A and B.
There's no A and B. We had a fancy word for the A and the B. The A and the B were called the... Starts with an L. Ends in limits of integration.
Limits of integration.
Oh, the limits of integration. Ooh, tough guy. All right, so the A and the B were the limits of integration. There are no... What do I know that begins with an L and ends in limits of integration? Yeah. A definite integral is just saying how much area, we've got the limits. In an indefinite integral, the notation is just going to be this guy here. There are no limits of integration. It's a different question that's being asked. The question being asked is, what function, and I'm going to call this function big F of x, satisfies the condition that if I find big F's derivative, I get little f. This is an indefinite integral. With a definite integral, you're asking yourself an area question. How much area is bounded by the x-axis, the curve, x equals a and x equals b? On the indefinite integral, the question that you may not be able to read is what function, capital F of x, satisfies the condition that if I take the derivative of big F, I get to little f. We're okay? All right, so let's get the notation going over here. The indefinite integral of f of x dx is equal to f of x plus c. This guy here, the f of x is the integrand. The dx is your variable of integration. This guy here is the integral sign. No surprise.
Whoa.
No surprise there. Big F, what are we going to call big F? Big F, we've seen this before. Big F is the
Antiderivative.
antiderivative. Antiderivative. And C is called the constant of integration. Important to recognize here that C is a constant. It's your constant of integration. Some people like to call it Charlie. Miss Blakely at East End always asks her students, "Where's Charlie? You forgot Charlie. Did you leave Charlie at the store? Did you leave him at the airport?" We're going to remember to write the constant of integration. This whole thing over here, when you see that there are no limits of integration, this is when it's going to be an indefinite integral. Okay. Questions so far? Okay. So we now have in our lives two flavors of integrals, the definite integral and the indefinite integral. I want you to get up, find somebody you're not currently sitting with, explain to them the difference between a definite integral and an indefinite integral. Go find somebody you're not currently sitting with. Movement's going to happen.
Hey!
Hey, Aaron!
That's cheating.
That the definite integral is only about the bounded area x equals a and b in the graph, the x-axis. What? What? The indefinite integral is only what happens when you're defining the derivative equals regular.
A and B.
He said, A and B.
Now explain it
I feel like I need to take a picture and use this in blackmail.
That won't be blackmail towards any of us.
Blackmail towards you as a children.
No.
It would be a
No.
I mean, it's okay
All right.
to be on the
Everybody's good with definite integrals and indefinite integrals?
Yeah.
Okay, so the goal for the rest of today is to learn to dance backwards. We're going to do our calculus dance backwards. So everybody have a seat. Okay. There once was a time where we learned how to dance in the forward direction. Here's what dancing in the forward direction sounded like. I would say, hey, what's the derivative of x to the fourth power? And everybody would tell me. 4x to the third power. You're frozen for a little bit. I might say, hey, everybody, what's the derivative of sine of x? And everybody would tell me. Cosine of x. I might say, hey, what's the derivative of the natural log of x? And everybody would tell me.
1 over x.
1 over x. I might say, hey, what's the product rule? The derivative of the first times the second plus the first. There you go. I didn't hear you say a darn thing, but that's fine. Okay. We also learned the quotient rule. Low D high minus high D low, low, low. Okay. questions like, what's the derivative of
That's mine.
tangent of x?
Secant.
Secant squared of x. I then ask questions like, what's the derivative of e to the 5x?
E to the 5.
No, 5 times 0 is 5.
E to the 5x times 5, or 5 e to the 5x, sure. Okay, I also asked you guys questions like, what's the derivative of 1 over x?
Oh, negative 1
over
x squared.
1 over x squared.
Negative 1 over x squared.
The derivative of 1 over x is negative 1 over x squared. I asked you things like, what's the derivative of the square root of x?
1 over 2x. I mean, 1 over 2 to the square root.
Derivative square root of x. This is dancing in the forward direction.
1 over 2.
Oh, 1 over
Wait.
2 root
1 over 2 square roots of x. I then got a little bit crazy. I said, what's the derivative of arc sine of x?
Oh,
1
1 over square root of 1 minus x squared.
1 over the square root of 1 minus x squared. Who hasn't gotten a lifesaver yet?
Myra.
Myra hasn't gotten one. Polymon's not going to get one no matter what he does.
Oh, yeah, mine answered.
She's the answer.
All right.
Let's see, I got one.
Okay, the power rule. When you have x to a power, the power rule says
Bring it down.
bring the power down
Reduce the power by 1.
and reduce the power by 1. I might ask you for the derivative of arctangent of x.
1 over 1 plus x squared.
The derivative of arctangent of x.
1
1 over plus x squared. What?
Oh, so awkward. Derivative of arctangent of x is 1 over 1 plus x squared. That was dancing in the forward direction. The derivative is moving in the forward direction. The indefinite integral, we're going to learn to dance in the backwards direction. Because what we know about an indefinite integral, the indefinite integral is asking you what function do you know of that has this as the derivative. Everybody okay? All right, so let's do it. Let's do 1 or 2 of these together, and then you guys are going to get some practice time. Aaron, can you tell me, how would you read this first one?
You asked me.
Yes, I asked you, how would you read this first one?
The indefinite integral
Yep.
of 6x minus 2
The indefinite integral of 6x minus 2
with respect to x.
with respect to x. Tell somebody near you, what does this mean? What's the question that I'm asking?
You're asking
What's the answer?
what's the antiderivative of 6x?
But what I'm really asking, right, the way you would read it is indefinite integral of 6x minus 2. But what I'm asking is, do you know a function that has 6x minus 2 as its derivative?
Yes. No.
If so, what is it? What function do you know of that has 6x minus 2 as its derivative?
2x. 3x.
3x squared minus 2x. So let's just do a quick check here. Does that actually work? Now, the check step, just like in first grade when you learned about subtraction and your teacher always had you check the work, they had you do addition.
Yeah.
And then you learned division and the check step was multiplication. David's like, I never did the check step. I know you didn't. If the antiderivative, stay with me, if the antiderivative of 6x minus 2 is 3x squared minus 2x, how am I going to check it?
The derivative of 3x squared minus 2.
Right? But I want to see the derivative of 3x squared minus 2x. What is that? 6x minus 2. Check it works. The antiderivative of 6x minus 2 is 3x squared minus 2x. Now here's the thing. That is one answer.
X is
There are other functions that have 6x minus 2 as the derivative. Not 2x cubed, because my goal is to get to 6x. Anybody know of another function that has 6x minus 2 as its derivative? I'm hearing 4x squared, but the derivative of 4x squared is 8x, not 6x. As soon as I write the first one, you're going to see all of them. Does anybody know another function that if you took its derivative would get 6x minus 2? I can think of an infinite number of such answers.
Whoa.
Nobody's going?
Oh wait. No, never mind.
give us six plus one.
Any other function that if you took its derivative would get you 6x minus 2. Andrew, what are you saying?
Oh wait.
Andrew, what do you got for me back there?
Wait, x squared minus 2x plus 1.
3x
Yeah,
squared
you
minus
just write any
2x
other
plus
number
1.
at
Plus
the end.
eight.
Yeah, you could write any other number.
Does
at
that
the
work?
end. Yes.
Yeah.
All of them.
Anybody get another one?
All of them with a constant.
That's
Like
one.
3x squared minus 2x
That's 100.
plus pi.
Okay.
3x squared minus 2x minus 100. The best answer is going to be 3x squared minus 2x plus c. That constant of integration, what it gives you, I want to make sure you get the word for this, it gives you a family of functions. Not just one antiderivative, but a whole family. By having that Charlie in there, you're saying, oh, any function that has this form, 3x squared minus 2x plus Charlie, is going to be the antiderivative, because what do we know when I take the derivative? The derivative of 3x squared is 6x. The derivative of negative 2x is negative 2, and the derivative of a constant is 0. Everybody good?
G.
Okay, so this guy here is giving you like your family of functions. Ms. Cooper at Southeast likes to call it family of functions. All right, let's see what we can do with this next one. The antiderivative, or the indefinite integral of 10 e to the t power plus sine t plus 6. Talk to somebody near you, see what you can do.
Do the same thing.
Yes.
Looking for a function that when I take its derivative is 10 e to the t plus sine t plus 6. Maybe you want to attack this in parts. All right, so my favorite wrong answer so far is e to the 10t plus cosine t. Favorite wrong answer. What's wrong with it?
It's negative.
Negative.
Paulo on something that's wrong.
Oh, this goes and.
Okay, first of all, it wouldn't be cosine that I would take a derivative of to get to sine. It would have to be negative cosine. That's part of why it's wrong. There's another reason why this is wrong. Think about the derivative. Celeste, what happens?
Oh,
You need to have plus 6x at the end.
Plus 6x. Oh, that's a new favorite mistake. That's a new favorite mistake to make.
wait.
Oh, 16, my bad.
16. Okay, we're still not
Oh,
there.
yeah, 60. Doesn't make
Stephen,
sense.
what else?
You didn't put the 10 in front of E.
Okay, first of all, there needs to be a 10 over here. Still don't have the right answer.
Oh,
Still don't have the right answer.
oh plus.
Andrew?
Plus C.
Okay, plus C, for sure plus C.
It's because of the first one.
Yeah, the problem is over here.
Yeah,
Think about what happens when you take the derivative of 10 e to the 10t.
Why is there 10?
You'd have 10 e to the 10t
No.
times the derivative of 10t, which is another 10.
Wait.
It's just going to be 10 e to the t.
yeah, because E stays the same as the derivative.
Right, when you take the derivative of 10 e to the t minus cosine t plus 6t plus c, the way you take the derivative here, it's going to be 10 e to the t minus cosine t becomes plus sine of t plus 6. That is right. There are a whole lot of integration rules that we're going to learn over the course of the next couple of days. For right now, I'm not willing to tell you any of them. You're going to uncover as many of these as you can. So what I want you to do is take the next 10 minutes. I'm going to check in with you guys from time to time. The goal is to complete problems 3 through 10. I am not going to tell you a single integration rule. Your goal is to come up with the original problem. And for now, for today, I want to see the check step. We're not always going to need to see the check step.
Minus. Yes.
Remember that you're learning to dance backwards. So in this first problem, the part that seemed pretty straightforward for everybody, antiderivative of 12x cubed is 3x to the fourth. That one seems to be causing problems for folks. And what would I take the derivative of to get to pi? Pi times x. Don't forget Charlie. What would I take the derivative of to get 1x to the fourth? Well, think about what happens with the power rule. Lewis, what's going to happen here?
Well, I know the answer is 1/5.
Oh, the answer is going to be 1/5 x to the fifth. Convince me that 1/5 x to the fifth is going to be the right way to go.
Because you bring the power down, and that'll
The
be
power rule says bring the power down and multiply. 5 times 1/5 gives me that one. And if I go over here and I do my check step, the derivative of 3x to the fourth minus 1/5 x to the fifth plus pi x plus c. 4 times 3, I get 12x cubed, minus 5 times 1/5 is 1x to the fourth, plus pi, that works. I'm not going to require you guys to do the check step all the time, I promise.
Oh, this is.
Friends over here.
So number 2, cosine theta plus sine theta.
This is just, you're learning all the old rules. You're just going back to it. And there are rules, oh my God, there are some integrations, there's coming our way.
But not yet, Andrew. Love it.
Something about it.
See, one of the rules in chat.
I agree with you, but if you took the derivative of negative cosine theta, you get positive sine theta. But the derivative of negative sine theta, David, would be negative cosine theta. So it's not, there you go. Don't forget about the All right, number 4 should be negative cosine theta plus sine theta plus Charlie. Number 5, I'm asking the question, what do I know that when I take the derivative I get 1 over 2 square roots of x? Gosh, is there something? And this would just be square root of x. Plus, is there something that I know I can take the derivative of and get 1 over x? Natural log of x. And then always plus c. And for any of the calculus teachers that are watching right now, we're going to come back and have this conversation tomorrow. Right now I'm going to let this be the wrong answer, and it's okay for today. Just for today.
Oh, you're right.
There are going to be problems. Yeah. Okay, keep going. Keep going.
I'm gonna ask you if this is.
Yep.
It'll be -5. Yeah, negative
Do
5
R
cosine
running this to the left of it like this.
Would that be legal?
Yes.
No,
Yeah.
plus sign.
Okay.
Yeah, so the better way to write it would be -5 cosine of x.
Yeah. Okay.
Yep.
You can just bring it up. You just leave this over here. And just do that.
So,
Leave the bottom there.
cosine of x is the first part. Has anybody figured out what would you take the derivative of to get sine of 5x?
Just kidding.
What would you take the derivative of?
You would take the derivative of, you would take the derivative, I just took the derivative of sine of x. Are you talking about the first part or the second?
To get to the second part. Right, because the question here is what function do I know of that has sine
That's
5x
just the
as
chain
the
rule.
derivative? And this is a chain rule.
Yeah.
What would I take the derivative of to get sine of 5x?
Whole thing first.
It's going to have to involve something with cosine 5x. But I want to be careful because think what the chain rule tells me to do. The chain rule would say the derivative of cosine is negative sine, that's a good thing. Leave the angle alone. What does the chain rule tell you to do though?
Multiply
Multiply by 5.
Oh, so times, yeah.
So to balance it off, I'm going to have to multiply by 1/5.
Oh, okay.
Right? Because when I take the derivative involves using a chain rule here. Okay, for those of you that are like, oh my god, there have to be some rules, absolutely the rules are coming. Tomorrow. Antiderivative of e to the x, I hope everybody's got this one.
E to the
E to the x, the antiderivative of e to the negative x. What do I take the derivative of to get to e to the negative x?
It was times negative 1.
E to the negative.
Yeah.
It would have to be negative e to the negative x. Negative e to the negative x. What would I take the derivative of to get e to the 2x? I keep hearing e to the 2x. I like it, I don't love it.
1/2.
Right, think chain rule. What does the derivative tell you to do? It would be e to the 2x times 2. I don't have times 2, so I'm going to have to do times 1/2.
Happy fall.
Yep. All the friends doing okay? Ish. Ish. All right, now for the problems that I would never ever get to in an AB class. I'm really curious to see what you guys can do with 8, 9, and 10.
What?
We'll talk in 3 minutes.
That's right.
I think I'm doing it right.
Over 6. Minus. Where?
Some of you all are definitely figuring out the patterns. The rules are coming. Don't be absent tomorrow. And whatever you do, don't be absent Wednesday.
Well, it's happening Wednesday.
Now, Wednesday, you guys have the senior service trip.
We're not gonna miss this. What's happening? What's supposed to happen?
All right, if all goes well, 1/6 t to the 6 minus 1/5 t to the 5th plus 1/4 t to the 4th minus 1/3 t cubed plus 1/2 t squared minus t plus c. How many guys honestly had that as your answer? Nice. Now there was number 9. 10 times 3x squared minus 2x to the 4th times 6x minus 2. Where, oh where would you ever see that as your derivative answer? Right? The indefinite integral, I'm asking you what function has this as its derivative?
Chain rule?
And you want to think chain rule.
Yes.
This is definitely a chain rule problem. Where's the baby?
3.
Oh,
If you see this as chain rule, and this is the baby,
Oh, so it's 2.
Oh, I get it.
okay, I'm hearing a lot of, okay, there's going to have to be something with 3x squared minus 2x. Raised to what power?
To the 5th power.
To the 5th power.
So you put a 2 in front.
Which means you're going to have the 2 in front, because the chain rule would say 5 times 2 is 10, 3x squared minus 2x to the 4th, times the derivative of the inside, which is 6x minus 2. And this isn't the right answer, Polymon, because... No, this is the antiderivative. This is the function that when I take its derivative, I get over here. It was something easier than that. Plus Charlie. Okay, nice. Good luck with the next one.
Oh, that's not it. Oh, okay.
Cosine of x times natural log of x plus 1 over x times sine of x. How would I ever take the derivative of something and get an answer that looks like this?
Use this.
I mean, I taught it. I don't know if you learned it. Something times something plus something times something. Gosh, where would I ever get that?
Yeah, right?
Cosine of x times natural log of x plus 1 over x times sine of x.
Yes. Yes, you're right. You are so smart, Myra.
Okay, I think the cat's out of the bag now. When would I ever see an answer that looks like 2 things multiplied together plus 2 things multiplied together? Would be from a product rule. So now you've got to figure out though, like, what are the 2 things that are getting multiplied together? And the 2 things that are being multiplied together are sine of x and the natural log of x. Because what would the product rule tell you to do? It says take the derivative of sine of x, which is cosine, leave the natural log of x alone, plus now you leave the sine of x alone, times the derivative of natural log of x, which is 1 over x. And then plus Charlie. All the friends okay? These are not the kinds of 9 and 10 are not the kinds of problems I'd be worrying about in the AV class right now. I'm also not worried about you guys too terribly much. These are all supposed to be challenge problems. See what you can do with like 1 and 2. And if you really want to show off, try number 3.
Bless.
So I hear a lot of folks trying to do a quotient rule thing, right? And I think it's the x squared in the denominator and the fact that it's a fraction. You might make some progress there. Anything else that you can do that maybe might make life a little bit easier? Helen, what else would you do that would be legal?
Move the x squared up.
What do you mean you moved it up?
Oh, so like x plus 1 times x to the negative 2.
X plus 1 times x to the negative 2 dx. Okay. Is that better? Maybe. Is it legal? Sure. I don't know that it gets me any closer to seeing the answer. But I think you're onto something here by like algebraically manipulating the integrand. X plus 1 over x squared could be rewritten this way. Another legal way to rewrite this, how about x over x squared plus 1 over x squared? Is it legal? Okay. Instead of x over x squared, how about 1 over x? I think you guys know exactly where this comes from. Plus 1 over x squared. Well, the antiderivative of 1 over x, what do we take the derivative of to get here? Natural log of x. What do I take the derivative of to get 1 over x squared? This is close to one that you should have memorized.
X.
Right, the derivative of 1 over x is the negative of 1 over x squared. So how do I get positive 1 over x squared? You take the derivative of negative 1 over x. So natural log of x minus 1 over x plus c. Derivative of natural log of x is 1 over x. Derivative of negative 1 over x is positive 1 over x squared. All the rules are coming tomorrow, I promise. Today is just meant to push your thinking. Keep going, we'll talk in a minute. It is totally okay to work in that integrand.
What would the derivative here be using the chain rule? If I use the chain rule, 3 comes down, 3 times 1/3 is 1. Cosine of x, the whole thing squared, times the derivative of cosine of x, which would be 1.
Over here, when I first went from x plus 1 over x squared to this guy, I was just rewriting the integrand. We still need that integral sign.
I mean, I could.
So if you can rewrite the integral in front of dx, and then over here we're still just doing some algebra to rewrite. Still need the integral, still need the dx. Is that legal? Right, you're just doing some algebra.
It's easier.
Yeah. And so then the antiderivative would be 1/4 x to the 4th minus 2x squared. So folks that are making progress with number 2 have distributed the x through to get to x cubed minus 4x. Notation conversation, like right now all I'm doing is rewriting the integrand using some algebra stuff. I still need to have the integral and I still need to have the dx. Hopefully once you get here then the problem becomes a little bit easier. What do I know that has x cubed as its derivative? 1/4 x to the 4th minus, what do I know that has 4x as the derivative? 2x squared plus Charlie. How many guys honestly had that as your answer? Good, 1, 2, nice. I'm really interested in figuring 4. Is that really a thing? Is it really a thing? Sine squared of x plus cosine squared of x. That's a thing?
It's square, but not the original.
It is the thing, but I'm trying to figure out how like you equal this to 1.
Oh,
Which means that your integral, what would you take the derivative of to get 1 Let's try that.
Yeah. I just
So what?
we can go to the one time.
So what would you take the derivative of to get 1?
Nice, nice, nice. All right, the cat is way out of the bag on number 3. Sine squared of x plus cosine squared of x. If you can make your life better by some trig, do that first. Sine squared of x plus cosine squared of x is really equal to 1. Now, be careful. You still need the integral sign and you still need the dx. And now the question is, what do I take the derivative of to get 1 is the answer? It's going to be x plus Charlie. Remember, I want the whole family of functions, not just one member of the family. I want the whole family. All right. See what you can do with number 4. Popular wrong answer is 1/3 e to the x plus e to the negative x cubed plus c. Is the most popular wrong answer. That's not the change rule I know. How old the change? You can bring the power down.
Oh.
And then there's something else.
Yes.
No, no, not nice. All right, we're totally running out of time, and I want to make sure you guys get this one in your notes. A legal thing that you could do that could make your life a whole lot better. How about multiplying this out? Just check it out. E to the x plus e to the negative x, e to the x, e to the negative x, e to the x times e to the x, e to the 2x, e to the x times e to the negative x is e to the 0, which is 1. E to the negative x times e to the x is e to the 0, which is 1. E to the negative x, e to the negative x is e to the negative 2x. So I can rewrite my integrand as e to the 2x plus 1 is plus 2 plus e to the negative 2x dx. First of all, is that legal?
Yes.
Like, just algebra. Algebra is always legal. Now, is it better? Do I know how to take the antiderivative of e to the 2x? What would I take the derivative of to get e to the 2x? Where would this come from in a derivative problem? It's going to have to stay e to the 2x, but times a half. What would I take the derivative of to get to 2? 2x. What would I take the derivative of to get e to the negative 2x? Negative 1/2 e to the negative 2x plus Charlie. Okay? Tonight's homework has nothing to do with integration. Your integration skills are going to get better because you're going to spend tonight working on your derivative skills. So things just are a little more natural. See you later.